So hey guys, in this lecture we are going to talk about throughput. So basically we talked about latency. So the second thing in the queue is throughput. The second application characteristic is throughput. So basically throughput is defined as, if we talk about the layman's definition, it's the rate of doing things. It's the rate of doing things. For example, if we are going to a saloon, so we might have seen that there are multiple chairs, and I mean, a team of three is there to help us with their services. Cool. So in a saloon, if there are three chairs, so and each customer, for example, gets a shave or a haircut in 1 minute. 1 minute. So the rate of doing things here is three customers per second, means they can serve per minute. So they can serve three customers within that time, because they have three seats, three chairs where they can do the hair cutting or the shaving part. Cool. So in the programming world, if we talk about the similar thing, the number of requests, number of parallel requests per unit time, or we can say per second, is the throughput. So if, for example, if we have only three chairs, and if the fourth customer comes, he has to wait for this queue to complete. He has to wait. So the process flow here is, basically, I'll write it again, rate of doing things. This is the main definition that you need to know. The number of parallel requests. Cool. So the process flow rate is something like this. This is the server. This is the internet. Cool. This is the quantity of data. This is the modem, and this is the end device, the last step. Cool. So the throughput here will be, also we can define it as the inventory upon the flow time. So this way we can derive another formula for throughput, that is inventory, means this thing divided by the flow time. I hope you guys have understood what is the basically inventory means. The inventory is the number of units contained in the process. So that's the inventory thing. I'll just write it again. Cool. So throughput can also be written as inventory upon the flow time. Inventory is the number of units contained in the process. Cool. So now we can define it in another style, that it's the flow rate. From here we derive that if we divide inventory by time, it gives us the flow rate, and the flow rate is also throughput. We can also call throughput as the flow rate. So this is another definition of the same. Let me take another example, or a short question, you might say that. For example, if in a production company, I need to make screws. I need to make screws. For example, if we have to make 100 screws, the total quantity is 100, and one screw is made in 10 days. One screw is made in 10 days. It might seem that why is one screw take? So it's just an exemption, it's just an example. You don't need to relate it with real world. Cool. So the throughput here, if we calculate, will be 10. How? It's the inventory divided by the total flow time. Cool. So the throughput here will be 10. Now let us look at the sum of the causes that result in low throughput. Let define some cases for low throughput. Cool, guys. So let me just write the heading: causes of low throughput. Cool, guys. So the first one is congestion or many requests. It's like a traffic jam. Like in traffic jam, if we want to go from a destination to b destination, from a to b, then if there's lots of traffic jam, then the time between the travel is highly increased. In the same way, if there is congestion, it results in the low throughput. Second is the protocol overhead. So we can explain this like, if there is certain way to go from A to B, and we need to cross this, for example this overbridge, or we need to cross this, then only we can reach this destination. So there are certain rules for us that we have to maintain for communication. So these protocols overhead also sometimes cause a low throughput. And the third one is the latency part. So in the previous lecture, we already have defined latency. So I think that it will be clear that how latency will affect the throughput. Cool. So you need to remember these 3 points. Sometimes it's directly asked what are the causes of low throughput. So you need to explain these points to the interviewer in detail, like I told you, so things will be clear. Now we'll look at the impact on the architecture, impact of this application characteristic on different architecture. Cool. Now, so firstly we'll talk about monoliths. So for monoliths, we have limited resources. Cool, guys. We have a single code base. Single code base. Third is we have a single machine. So automatically we have a limited throughput because our inventory is limited. On the contrary part, if we talk about distributed thing, so in the distributed point, there are multiple machines. Load balancers are present. We'll also talk about load balancers in very detail in the coming lectures. We have ample resources. So automatically, here the rate of doing things will be far better. Cool. So this was the impact of throughput on the different architectures. So now let's look at the next thing, that is how we can improve it. So it's like we could use CDN. CDN I already discussed. We can do caching. We can improve the quality of the hardware or software that we are using. We need to fix bugs and we need to upgrade things, software. Fourth one is load balancers. So load balancers actually help in decreasing the, it helps in improving the latency. So if latency improves, automatically the throughput will also improve. Cool. So that was all about this lecture. I hope you guys have understood what is throughput and how things are revolving around throughput and what all factors are affecting it. So we'll meet in the next lecture with our next topic. So thank you everyone for joining.